because today will be the last class for this week, and we'll continue back next week. So yesterday we actually stopped at one example which involves loops, but then we are dealing with array. Now take note that whenever you're dealing with array, you cannot avoid the usage of pointers. In this case, is FSR. So we will continue with the topic of chapter 2. So the next topic is, earlier you have already been introduced to pointers which is in data memory. The pointer in data memory are known as file select registers. And how many file select registers do we have? We have 3, FSR 0, 1 and 2. Now likewise, I did mention earlier in class that in program memory also there is pointer, but I'm not referring to program counter. So I'm referring to this one. So now we're going to learn about the pointer which can be used in program memory. Now earlier we have actually learned about the data directives which can be used to store data in program memory, right? What are those data directives? What are those data directives that we use to store data in program memory? Yes? Come again? Just voice out, never mind. If you make mistakes, it's fine. What is the directive that we use to store data in program memory? Program memory. I give you a hint. Usually it's done at the end of the program. What is the data directive that we use before the end of program?
DB, DW.
Yes. DB and DW is used to store data in program memory, right? So you should be fast if you have revised. So that DB and DW is used to store the data into program memory. But how do we actually retrieve it back? So in order for us to retrieve it back, we actually need to use a pointer. It's known as the table pointer. So the table pointer must have how many bits if we want to point to program memory? Do you understand the question? How many bits must the table pointer have in order to point to any location in program memory? Come again? 16. Any other answer? 1. Okay, let me just try to ask. The FSR is a pointer in data memory, right? How many bits is FSR? How many bits is FSR? 3 bits. FSR 12. 12 bits, right? Why FSR is 12 bits? Because? Why is FSR has 12 bits? That's my question. Okay. So what's with data memory that we need 12?
8 for the data, 3. 4 for the FSR, for the pointer.
4 for the?
For the pointer, FSR 0 or 1 or 2.
No, the content of FSR is 12 bits, right? Don't see I'm not asking about the instruction format. I'm asking FSR. FSR, the pointer, the FSR, the whole FSR is how many bits? Do you understand the question or no? FSR is a file register, right? It consists of 2 file registers. How many bits is FSR, I'm asking? 12. Okay, you said 12. I'm asking why 12?
Pointing at the data memory.
Yes? 2 megabyte. 2 megabyte is 2 million.
But it's used in the data memory.
I know. Why? Why is it 12? That's my question. I'm not answering the question. It's a very simple answer. Very, very simple answer. I have repeated this so many times. Actually. Why FSR has 12 bits? What does FSR do? Point, right? Point to where? Point to the address, right? You already got. Okay, I don't want to waste much time. FSR is 12 bit because the address of data memory is 12 bits. It is as simple as that. Do you get the logic? I did explain that a pointer, when you want to point to a particular address, it must have the same bit length as the address. If your address is 12 bits, your pointer also must be 12 bits. Why? Because you need to load the value to point to the address, right? If your address is 12 bits, now yesterday only we did the example load. Of course, yesterday's address was just hex 11, but in reality it was 0, 11, right? So you need to load the 12-bit value. Why? So that the pointer can point to the 12-bit address. Does it make sense?
Yeah.
So the same thing here. Table pointer is a pointer in program memory. How many bits it should have? 21. All these things are very, very basic understanding. After test 1 by right, you should have understood this. But I think still many foundations are still weak. At least you learned something. So the pointer here should have 21 bits. So because 21 bits, it consists of 3 special function registers. 3 special function registers joined together, total bits is 8 times 3, 24. But out of this 24, you'll be using 21 bits only. Same like FSR. FSR consists of 2 file registers, right?
Yeah.
2 file registers means 16, but out of 16, you're only using 12. So the table pointer has 21 bits and it consists of table pointer low, table pointer high and table pointer upper. So the same concept as in the FSR, the pointer. You need to load the value inside so that it will point to that particular location. So let's say if you want the table pointer to point at so we have program memory here, and let's say this particular address is hex 2000. You want the table pointer to point at this location. You want the table pointer to point at this location. Take note that table pointer actually is made up of 3. We just saw right just now, made out of 3 special function registers, which is table pointer low, table pointer high, and table pointer upper. So in order for the pointer to point at this address, you must load this address inside, right? Same thing like FSR. The only difference is FSR has an instruction to do that. But for table pointer, you don't have the instruction to do that. So what should be the content? This should be 0, 0. This should be 0, 0. Should be 0, 0. Right? You all agree? So when you load this value, the pointer will point at the address of the value which you have loaded. I mean, if you load the value 2000 inside, the pointer will point at address 2000. Do you all understand? Any question so far? Yes or no? So how do we actually do this? Since there is no instruction to actually load this value, you have to do it manually. That means you have to load each one of the values inside here. So how you do that is move liter value. Just show 1.00. Move WF to table pointer low. Of course, this one you can substitute another way also, right? How? Do you understand my question? Instead of loading the value 00, that you can also use another instruction to do the same thing. Clear? Yeah. Clear F table pointer low, same thing. So the next one, X 20 table pointer high. Then the last one we can try the other one, which is clear F table pointer equal. So when you do this, your table pointer will point at this address. Is that okay?
Yes.
Any question up to this point? So what I'm trying to do is I'm going to try to do the same thing here using that thing. So I'm going to add the table pointer here. Okay, if you see that there is when you drop down, there is table pointer. There is table pointer high, low, and upper. When you actually load table pointer, this table pointer consists of all these three. So you don't have to put separately. If you put separately, you can see only 8 bit, 8 bit, 8 bit. So table pointer, it will show the whole 21 bits. has 21 bits here. So now when I press 7, load 0, of course there is no change in 0. But then for the 20, you can see there is a change in 20. And of course, so this, of course, table pointer doesn't have the green arrow pointing, and these are only the PC has that arrow. So what I want to show is now, when you do that, you see the content, it will actually point at X 2000. Is there any question on the pointer? Is it okay? Now once the pointer is pointing to a particular location, next thing what we are interested is we want to actually retrieve that data, right? Earlier we have used DB to load the values, now we want to actually retrieve those data. So how do you actually retrieve those data? Is by using this instruction. By using these instructions. So you can see table read asterisk, table read asterisk plus, table read asterisk minus, table read plus asterisk. Now this is table read. Read means you're going to read the content of the location where the table pointer is pointing. Write means you're going to write to the location where the table pointer is pointing. So most of the time we do not use write because we will use DB and DW to actually write those values into program memory. So most of the time we're going to use the read. We want to actually read back the data from the program memory. Are you all following? So if you see the instructions for the read, there's read asterisk. This is table read. So this is something similar to the index in FSR. Does it increase the content of FSR index? No. Same thing here. If you use table read asterisk, it will only read the content of the file register which is pointed by the table pointer. It won't increase or nothing. There's another one which is table read with post increment. That means after you read, you increase the content. Then there's another one, after you read, you decrease. That means the pointer will go up, increase means go down. And then table read with pre-increment. That means you increase first and then you read. The same principle like the FSR. Is it okay? Now the thing is, when you use this instruction, the data will be read. But where will it be stored? Where will it be stored is in this special function register, which is known as table latch. Table latch is a special function register. Whenever you use that instruction table read, let's say just now we configure the table pointer to point at location hex 2000, right? Assuming there's some data here. So when you use the table read, it will actually extract the data, it will copy and paste it inside table latch. Is it okay? Whatever instruction that you use, whenever it reads, it will read from wherever the location is and it will copy into table latch. And then from table latch, you can actually take the data and do whatever you want. The same thing with table write. When you want to write, you actually have to load the values here and then you have the table write. But even though if you try the table write, it won't work. I have no idea why it doesn't work. So anyway, we don't use table write. We use DB and DW. So let's carry on with the same example as now in MPLab. So we have established that at 2000. Now let's say I want to now we have already initialized the pointer to point at 2000. Now let's store something at 2000. So how can I store something at 2000? In program memory, this move all is only at data memory. How do we store values in program memory? DB, DW, right?
Yes.
But now I want to store at hex 2000. How can I do that? How can I specifically store at hex 2000? By using origin. Have you forgotten? Use origin 2000. What am I doing? That means I'm starting to store at hex 2000, right? So let's say I put value 45, 5, and 35. So let's view program memory. The next 2000 you see? Start 45, 55, 65 and 75. Is that okay? Let's make this small. Let's also add table latch here, the watch. Table latch. So just to show you that how it's actually working. Sorry, if I use magnifying, it's difficult to see the program. So let's run this. So this is the part I've already loaded hex 2000. Oh, sorry, I didn't do anything right. I've stored the values. Now I need to use table read asterisk. Now, whenever this is our main program, right? And this is the part where we want to store. Here's where we store our data in program memory. But if you notice that the arrow will keep going down. So I don't want the arrow to go until the end. I want to halt the program here. So what I can do is I can actually do this. What am I doing here is I am putting this loop here to prevent the PC from going down. That means the program won't end. It just will get halted here. So we usually do this structure. We usually will do this when after the main program. This is our main program, right? This is our main. After main program, you have something to store, or when you use subroutine. You have subroutine. You need to. If you don't put this, what happens? The PC will go down and end up going straight to the subroutine as well. So this is one way of preventing the PC to go out of the main program. So at least you will halt it here. Of course, it will keep looping this part, but it will halt it here. Is that okay? So now we're going to use table read. So let's see the effect. What happens if we use table read? So if you can see, table pointer is already pointing at 2000. If you table read, what do you expect the content of table latch will be? This is at 2000. This is 2001, 2002, 2003. So what's the value that you think will come?
45.
45. 45 is at 2000, right? You see 45? 0.45. But does anything happen to the table pointer?
No.
No, because you're using table read asterisk. So it doesn't nothing happen. And it only reads because the table pointer is pointing at hex 2000. What is stored at hex 2000? Hex 45 is stored at hex 2000. So it managed to capture it. You understand? Any question? Yes, Aman.
Why do we have to mention
table before the initialization of the value?
This is actually not initialization, this is actually we load the values inside. So table read should be in the main program because you want to read the data in the main program, right? This is for you to store. Now take note that this is actually not instruction, which means that you don't have to wait until the PC to come to DB and then only it actually stores the value. No. This is assembler directives. Assembler directives means when you compile, you see before even I actually run, the values are already there. You notice this now, it's already there in 2000. Because DB means it stores. It is not an instruction. It is not instruction that you need to wait for the PC to come to execute, then only to store. No. DB means when I compile, see when I compile this, I have not even executed it yet, but if you go to hex 2000, the values are already stored. Because this is data directive, it stores when you execute itself.
So it is as low as data directives.
It is data directive. DB and heavily is data directive, but you store values inside program memory.
And it's not in program.
Usually it just be before the end. You won't do this in the main program, of course. Any other question? So now we have done that. So let's try to use with asterisk plus. So let's see what happens when you use asterisk plus. So table reads, it reads 45, but then what happened to the table pointer? It increases by 1. But then of course because I am not putting a loop here, it only managed to read 1. So let's say if I if I already put this, then this is not required. So let's see what happens now. I'm putting it 2000. At 2000 we have that 45. So you see I read 45, which is at hex 2000. The pointer increases by 1 at 2001. So when I read for the next time, see it reads 55 and increases the pointer by 1. And read again, it reads 65, increases pointer by 1. And read 75. Because if you read the next, it will be reading the whatever the next. Because inside the program by default will be FFF. So that's why you get FF. Is it okay? This is relatively quite simple. I'm not telling the point of lecture, I'm telling the point of student also. This is relatively simple. Is it okay? So that's how you use pointer. Pointer, you need to initialize the pointer and then you make sure you store the data somewhere, and you need to initialize the pointer to the location of your data. So this is one thing. Let me just try to save this so we can share. So next thing we're going to do is, sometimes this is one way of you to do this. And this, okay, you can use origin to start to load your data from this particular address. Sometimes if the example, there was one final question says that your data which is stored in program memory or your data set should be stored from address hex 2000 onwards. So in order to make sure, you can use origin to store. So another way is you can actually use label. So let's say you're going to name this as array. That means when you put a label array, db45 blah blah blah, all these things, what does it mean? This array is tagged to which address? Do you understand the question? Yeah, this array is actually tagged to hex 2000, which means it is tagged to hex 45. You can see here. Okay, I need to compile this first. When I compile, you can see at address you see it has the label. This array label is tagged to which address? 2000. So what we can do here is, there's another way that we can initialize the pointer. By using this syntax. Assume that the program location is actually the label. So when you want to actually, you don't have to know the address sometimes. You don't need to know the address. You can use this, you can use the label to actually initialize your pointer. But you must use this keyword, upper, high and low. You must use this keyword. So let's say in our case, instead of loading the value, we can easily use low array. This one is high array. And the last one is upper array. So when you do this, when you use this word low, high and also upper, array is actually tagged to this address, right? So when you use low, high and upper, automatically the low will take the lower address of array, high will take the middle portion of the array value and upper will take the upper portion. So you don't have to worry about the address. So it automatically it will do the same. So let's see. You see this? Each time it loads the value into working register. So you see actually also it configures the table pointer x2000.
So, the sequence is it fixed or?
Which sequence? This one? No, no. The sequence of this one must be low, high, upper, no. You can put upper in between, you can put low up, you can put here. You can arrange this in any sequence, but these three must be done at the same time. Don't do one here, then another one after the program. Then it will become wrong. The sequence is not fixed. You can do whichever way that you want. Is that okay? Now let's say I remove this origin. I don't have origin. But I'm straight away doing like this. Do you know where is the starting address of x45? If I do like this. Not hex 00. This 45 will be stored after this branch, right? But do you know where is branch located at? No, unless if you look at here, of course you know. Branch is actually at address 00. from here you know that the branch is finishing at address 0028. After branch, because you put DB, that means as soon as after branch, it will start to be stored, right? So 45, 55, 65 and 75. Can you all see this?
Yes.
But do you know the starting address of this 45 or not? Of course, from here you can know lah. The starting address is actually 002A. But let's say if in an exam when you're typing this, you won't know where is it located at. So how do? You don't have to worry, because that's where the advantage of label comes in. When you use label, like earlier example, we use origin hex 2000, we already know that the data is going to start from 2000. So the initialization part, we can have two options. One, we can do like this, using the low, upper and also high. Or the second one is the earlier one which we did. We manually load in the value, hex 00, hex 20 and hex 00. But in this case, in this example, we do not know the address of this 45. But you still, if you want to initialize the pointer to point at this first address, how do you do it? Is you introduce a label and then you just use low, high and upper. Automatically the pointer will be configured to this array. If you don't believe me, let's see. What's the address of table pointer? 002A, right? Is it the right place?
Yes.
Array 002A. So this is the advantage of using label and configuring the pointer by using upper, low and also low, high and upper. So in this way, do you need to know the address of 45? No need. You don't need to know. So you just introduce array and you just do like this. So passing question last time we has asked. So some students say, sir, I do not know the address. Do I need to create my own address? You don't need. You just put label and just do like this, low, high, upper, finish, and done. Irrespective of what the address is, it will automatically be taken care of. So you don't have to worry about where is it stored. Is it okay? So this is by using table read plus. If you read table asterisk minus, okay, the first one is read 45, but then what happens to the table pointer? It goes to the reverse one, so it will going to read D7 because it is going in reverse now. This is 45 going to read the previous one, D7. Then you will read FE. Then you will read 00 and you will read 08. So it's going backward. So likewise, if you use plus asterisk, plus asterisk, so it's already table pointer initialized to 2A because the label is at 2A. But then this one will increase first and then read. So what do you think the answer inside table latch will come? 55. You see, 55. Because it increased first and then read. Is it okay? So this is on the table pointer. So I'll share the code this morning, everything. So next we have logic instruction. So next week we can finish chapter 2 already. So I'll just take a minute. Kajian, Muhammad Daniel Ashraf, Muhammad Faiz, Muhammad Naim, Muhammad Abdul Salam, Muhammad Ali Farag, Muawiyah, Muhammad Nazirul, Muhammad Syafiq, Muhammad Syaril, Muhammad Aizat, Muhammad Faiz, Muhammad Hazwan, Muhammad Syafrul, Navin, Nanda Kumar, Haryati, Nur Syafika, Parvini, Ratna Kumar,